On this example, we are given an exponential function. Now we know that exponential function is, well, the inverse of the logarithmic function. So we can use the properties of logarithms in an exponential function by changing it into a logarithmic equation. So let's start with the problem. The problem is we have 7 raised to 3x equal to 20. And we're solving for x. Now in this equation, x is in the exponent, which is unusual to most equation or problems that we are solving. So to answer this type of problem, we need to use logarithm to solve for x. So what we can do is we multiply this side and the other side by logarithm, so we can apply the logarithmic property in solving for x. So by doing that, we have logarithm of 7 raised to 3x by multiplying logarithm times 7 raised to 3x, and we have logarithm of 20 by multiplying 20 in logarithm. Now, as I've mentioned from the previous example, if we have the same logarithm of the same base, we can cancel the logarithm and proceed to our solution. However, x this time is not just it's not just a term, it's an exponent. So this time you are going to use the power property to solve for x. So you cannot just cancel logarithm to solve for x. So using the power property, this term right here will be changed into 3x logarithm of 7 equal to logarithm of 20. And since we're solving for x, we need to have x by itself. So we can do 2 steps to have x by itself. The first step is to get rid of logarithm of 7. To get rid of logarithm of 7, divide both sides by logarithm of 7 so that this cancels out, and we'll end up with 3x. And x is still not by itself, so we need to get rid of 3. And to get rid of 3, we multiply both sides by 1/3, and we'll have x equal to a very complex expression. We have logarithm of 20 all over logarithm of 7 times 1/3, which will be simplified into logarithm of 20 equals logarithm of 7 times 3. Now, how can we further simplify this complicated expression? The only way to do this is to use the calculator. So we're going to use the calculator to solve for x in this problem. So to use the calculator, always make sure to use the parentheses to make sure that you're getting the accurate result. So I'm going to open a parentheses for logarithm of 20 divided by parentheses logarithm of 7 times 3. Which gives us 0.513167282, which we can round it up into 0.513. So x from this equation is now 0.513, or equal to 0.513, using the properties of logarithms, solving for x, and of course the calculator. So let's have more logarithmic problem that uses the calculator. We'll have the change of base formula. Now, before we can answer this problem, you need to remember the change of base formula is given by logarithm of m base n, where we can change it into logarithm of m all over logarithm of n. So logarithm of m all over logarithm of n. Okay, better. So we are trying to find the exact value of logarithm of 15 base 3. Now, you can't just use your calculator right away to produce logarithm of 15 base 3. You need to perform a series of steps to be able to get to your answer. So let me walk you through the process. So the first step is to use the change of base formula to solve for logarithm of 15 base 3. And using the change of base formula, log of 15 base 3 can be changed to log of 15 all over log of 3. So we have logarithm 15 all over log of 3, which we will simplify using the calculator. So now we know that logarithm of 15 base 3 is equal to, or approximately equal to, 2.4650. And how did we get 2.4650? We will use the calculator. So logarithm of 15 divided by logarithm of 3, which gives us 2.4649, and I rounded up to 2.4650, and then the next step will be to round it up to the nearest whole number. Now this is important because we are going to use this as our base to solve for x. So all we have to do for our next step is to copy logarithm of 15 base 3 equal to the new set of logarithm that we have to solve for x, which is logarithm of x base 2. And this 2, or the base 2 right here, came from our change of base formula. We know that logarithm of 15 base 3 is equal to 2.4650. So we'll replace or substitute this expression into 2.4650 and just copy log of x base 2. Since we're solving for x, we can change this equation into a exponential function by converting it from log to exponent. So to convert it from log to exponent, 2 raised to 2.4650 is equal to x. And using our calculator, we can evaluate 2 raised to 2.4650. So we have 2 raised to 2.4650. 2.4650, which gives us 5.5212, which is our value of x. So this is how we use the change of base formula, so we can find the exact value of logarithm of 15 base 3, which is equal to 5.5212. Now let's have the last example. And this time we're going to solve this from scratch. So the first step is to use the change of base formula for logarithm of 23 base 2. Logarithm of 23 divided by logarithm of 2 using the change of base formula. Let me rewrite logarithm of 23 base 2 so we can use it to our equation later on. So we have logarithm of 23 base 2 equal to logarithm of 23 all over logarithm of 2. Now we're going to use our calculator to produce logarithm of 23 all over logarithm of 2. Which gives us 4.5235. So I'll have 4.5235, or 6 to round it up to the nearest 10,000ths, which is approximately equal to 5. Once again, we need this whole number as our new base to solve for log of 23. So next step, logarithm of 23 base 2 is equal to logarithm of x base 5. Now we know that logarithm of 22 or 23 base 2 is equal to 4.5236. So let me rewrite it into 4.5236 equal to logarithm of x base 5. And the last few steps would be to convert logarithm or this logarithmic equation into exponential function. So we have 5 raised to 4.5236 equal to x. So 5 raised to 4.5236 is equal to x. And using our calculator, 5 raised to 4 5236 is equal to 1451.65. And this is the value of our logarithm of 23 base 2 using the change of base formula.